subtracting rational expressions. Looking at the lesson opener, my first problem is 2/3 plus 4/5. Well, to add fractions together, we have to have a least common denominator.
It's kind of like having matching kicks.
Well, I have a denominator of 3 and a denominator of 5. What do they have in common? Well, 15. So my least common denominator here is 15. So what do I need to multiply 2/3 by so I can have a denominator of 15? Well, 5. Now I'm going to multiply by 5 divided by 5. That's a creative form of 1. This is an expression, so I can't just multiply by whatever I want. 4/5. What do I need to multiply by? 3.
Make sure when you multiply by the creative form of 1 that you write it as 3 divided by 3, 5 divided by 5. Just saying times 3 is incorrect math notation.
So now I have 10/15 plus 12/15.
The shoes are the same.
So we can add the numerators and get 22/15. Now looking over at number 2, I have 2/3 minus 7/12. Well, my denominators are 3 and 12. Well, what do they have in common? 12, right? Because 3 times 4 is 12. So I don't actually have to multiply to 36. I want the least common denominator so I don't have a ton of simplifying at the end. So then I just need to multiply that first fraction by 4 divided by 4. And I have 8/12 minus 7/12, which is 1/12. Looking at this third one, now we have an expression that has values and variables. So let's pay attention to those denominators. I have 3x and 6y. Let's focus on 3 and 6 first. Well, they have a 6 in common. Okay, the first denominator has an x and the second has a y. So I'm gonna need both of those in my least common denominator. So it looks like 6xy. What does the first fraction need from that least common denominator? It needs to get to 6, so I'm gonna have to multiply by 2/2. It also needs a y. It already has an x. So multiplying by 2y divided by 2y. Second fraction, well, it already has the 6, already has the y, so it's just gonna need the x divided by x. Awesome. Well, check it out. Now I have 4y squared divided by that least common denominator minus 7x also divided by that least common denominator. So now we can subtract our numerators. They aren't like terms, so I'm just gonna get 4y squared minus 7x all divided by 6xy.
Let's find the least common denominator on this next one. We have x squared y. So 2 x's, right? And then in my other fraction, I have a 2xy. So I already have an x represented and a y represented, but I don't have the 2. So let's write that one down as well. Now we have to determine what to multiply each fraction by to get the same pair of kicks. Ooh, on this first one, I only have to multiply by 2 divided by 2. And on the second one, I only need x divided by x. We're gonna have a little bit more work to do algebraically in that numerator because I need to multiply that 2 into 6x minus 1. So be careful with your notation. Don't miss a step. So let's simplify our numerator now. Okay, to recap, once I had the same denominator, I'm allowed to go ahead and add the numerators. I also needed to distribute and then combine like terms. Last thing, it says to state the restrictions on the variables. So looking at our fractions, once again, thou shalt not divide by 0. What can x not equal? What can y not equal? Well, both of them are restricted. They're not allowed to equal 0. The next example, it's a little hard to see what the matching denominator is going to be. So I need to factor. Pausing on that second fraction, do you see that we have a GCF? Don't forget to start strong. Whew, let's take a look at the least common denominator, that first fraction. The denominator is x minus 6, x plus 2. And then when I take a look at the second fraction, the denominator is 4 times x plus 2. Well, I already have the x plus 2 written, so all I need to do now is write the 4. So it's a lot easier to see what my creative form of 1 has to be for each of them. The first fraction is missing a 4, so I need to multiply by 4/4. The second fraction is missing that x minus 6. So they now currently have the same denominators. I'm allowed to go ahead and subtract the numerators. Be careful because once again, we have to account for multiplying and distributing. Don't do that all at once because when it's subtraction, it's really easy to make a little mistake. Okay, so in the numerator, 4 times 1 is 4, but then it's a minus and I have 3x times x minus 6. Do you remember why that's so important to be careful? We're distributing a negative 3x, so I'm gonna do that in the next step. after I write my denominator. It's not okay to drop your denominator and then all of a sudden have it pop back in at the end. Gee, Miss Ryan, this is interesting. It looks like I could go ahead and divide out my x minus 6's.
She just divided across subtraction. Can't do that.
Don't do that. Okay, so let's go ahead now, simplify the numerator. I'm going to distribute the negative 3x. Okay, so we distributed the negative 3x, and remember that when I distribute negative 3x into negative 6, we get a positive 18x. That's kind of the most common error in that type of problem. It's kind of common practice to make sure that numerator is in standard form. So I rearranged it in standard form. Now state the excluded values. Thou shalt not
Divide by 0.
So let's just go ahead and say what those are. Let's see, if x were 6, 6 minus 6 would be 0. If x were negative 2, negative 2 plus 2, 0. So those are the excluded values. X cannot equal negative 2 or 6. Time for you to show your skills. Check out the next problem. Remember, you need to factor everything and don't forget to start strong.
Let's check your work here. Notice we did not divide out this x plus 4 and x plus 4 here. That numerator, it's all addition, so it's like in a big giant bear hug. We can't divide out that x plus 4. So that leaves us with this final answer. Don't forget to state those restrictions. X can't equal negative 4 or negative 1. Looking over at number 6, the first thing I want to do is factor, right? But there's nothing here to factor. So I'm going to have to jump straight to finding my least common denominator. Looking at that first denominator, I have x minus 1. Okay, so I'm going to need that. Then looking at that second denominator, 2x plus 1. Well, I don't already have that, so I'm going to need that as well. Bummer. So now when I'm multiplying by my creative form of 1, my first denominator is going to need 2x plus 1, and my second one's going to need x minus 1. Whoa, look at this fraction. At least it's all written over one nice least common denominator, but look at that numerator. I got so much going on up there. Did I simplify out? Hey, like this 2x plus 1, 2x plus 1? No, this is addition in the numerator. I cannot divide those out. So that means we're gonna have to multiply out both of those in the numerator and then combine like terms. So take a moment, be really careful, multiply out. Whew. Okay, so I multiplied out that first set to get here and then that second set to get here, but now I'm just set up so I can combine like terms. So combine like terms, get your final answer, and state your restrictions. Look at that beautiful final answer. All that hard work really did pay off. Notice my restrictions. I have restricting 1 and I'm restricting negative 1/2 because of that 2x plus 1. Looking at this next one, I think you can do this. Make sure you factor, start strong on that first denominator, find that least common denominator, and simplify.
First fraction factored out to x times x minus 1. Well, the second fraction already had the x, so I just had to multiply by that x minus 1 over x minus 1, simplify the numerator, bring it together. Our restrictions were x can't equal 0 or 1. Now you might ask yourself, why do they consistently simplify that numerator, but then they never multiply out the denominator? Well, the denominator is already simplified in factored form. We never want to do any more work than we have to get it into simplest form. So leave the denominator factored. We do multiply out and simplify the numerator because most times it's not in simplest form. This example, we see that we have 4y minus this fraction. So at first glance, you're not thinking fraction minus fraction, but it is. We just, of course, want to write it over a 1. Now, what's our lowest common denominator going to be? Well, that's just going to be that second denominator.
Don't you need to factor it?
Factoring's always good, but in this case, we really don't have to, other than to get our restricted values. So to do the problem, I won't factor it yet. Okay, we have our least common denominator. I pulled it together. Look at that second fraction. When you pull it together, we're subtracting it. So you gotta hug out the y plus 2, or you might forget to subtract all of y plus 2. Let's distribute the 4y and simplify that numerator. There was nothing to combine once I distributed the 4y and distributed the minus sign into the y plus 2. Now all we need to do is state the restrictions. Well, here's when I might need to go ahead and factor that, because we want y squared plus 3y to not equal 0. It's going to be easier to see what those restrictions are in factored form. So y cannot equal 0 or -3. Simplifying complex fractions. The cool thing about this is we've really already done it. We've already learned how to multiply and divide fractions. So in this first problem, we have x divided by y divided by p divided by q. Now when dividing a fraction, what do? We multiply by the reciprocal. So x divided by y divided by p divided by q. I'll keep the first fraction multiplied by the reciprocal of the second fraction. Remember, you always have to flip the second fraction, keep the first. So this is just xq divided by py.
Wait, so you didn't need a common denominator to multiply?
No common denominator needed when you multiply or divide. Finish out this row. Remember to change it to multiply by the reciprocal. Don't skip the step.
Let's check your answers. Pay close attention to number 4. Did you notice how the q plus 1 could divide out? Remember, hug it out, divide it out. Why don't you go ahead and start 5? See what simplifies out of that one. Checking number 5, I could divide out that 3y pretty quickly, but notice when I get to x squared minus 4 divided by x plus 2, I could totally factor that numerator and divide out an x plus 2. Final answer, x minus 2. Looking at number 6, okay, I have x divided by y divided by p, so that kind of looks a little goofy. Let's really emphasize that division. So I'm dividing by p, just put p over 1, that way you can still multiply by the reciprocal. Then we end up with x divided by py. Go finish the next two. Number 7, I get 5 divided by 3 times n minus n. Okay. Number 8, really be careful. Don't take any shortcuts here. Yeah, the x plus 7's divide out, but when I multiply across, that leaves me with 5 divided by y.
Woo! It's like we're pros at this now. Simplifying complex fractions. Wait a second. This one doesn't look exactly like a fraction divided by a fraction, because when I look at that numerator of this complex fraction, it says 1 divided by x plus 3. So it's actually a sum and it's not written as a single fraction. That's a problem. Look at that denominator. It says 5 divided by y plus 4. That's a sum that we haven't taken yet, and we don't have it written as fraction divided by fraction. So the first thing we need to do is rewrite this complex fraction so that it looks like a single fraction divided by a single fraction. In the numerator, we have 1 divided by x plus 3. So we need to combine that into one fraction. That's why we practice adding fractions. I see that the least common denominator in 1 divided by x plus 3 is just x. So I'm going to multiply 3 by x divided by x. That gives me 1 plus 3x all divided by x now. Okay, really highlighting that now I'm going to do a whole separate problem in the denominator of this complex fraction. Whew! So this time I need to multiply the 4 by y over y divided by y, in order to get a common denominator for the denominator of my complex fraction. So that gives me 5 plus 4y divided by y. Now it's just like above. Multiply by the reciprocal and we're done. You might ask, should I distribute? You could, but there's no good reason to at this point, so just leave it. So in this next one, I have -3. That's all fine and good, but look at that denominator. 5 divided by x plus y. Can't have that sum there, so let's go ahead and add it up and make it a single fraction. Need to multiply the y by x divided by x. So now we have -3 divided by 5 plus xy divided by x. Now it's fraction divided by fraction. Well, the -3, remember, you can think of that as -3 divided by 1. And there's our final answer. Whew! All right, finish that last example. All right, so I wanted to point out that you already knew how to do this, but there is an alternate choice. If we want to simplify this, we could still just think of it as what is the LCD for each of these. So I have x plus 2 in that first fraction, and I have x minus 1 in the second fraction. So I can just multiply by a creative form of 1 using the LCD. Check this out. So I'm multiplying by a creative form of 1, but now it's really important that you kind of see what's happening. I take the numerator, this 4 divided by x plus 2, and I'm multiplying it by x plus 2 times x minus 1. Well, in that case, the x plus 2's would divide out, leaving me in the top with 4 times x minus 1. Now I want to look at the denominator, which is this 3 divided by x minus 1, and it's being multiplied by x plus 2 times x minus 1. What divides out there? Well, the x minus 1's, leaving 3 times x plus 2. So you can see that you get an equivalent statement. You can do it either way. It's always nice to have a couple extra tools in our toolbox.
Whew. I got skills. They're multiplying. Oh my gosh.
I'm better with a song. You know you belong. What's wrong?